Ready, dudes? Thank you, KJ. Okay, so this lesson, you know, if I kill you, there wouldn't be a jury in the world that would convict me. Yeah, exactly. You see, they know the deal. They know the deal. Okay, double angle. Now, these formulas really are just extensions of what we did last time. So, for example, what's the formula for sine twice the angle? Well, you realise, I can work this out by just using, A plus A, which will be sine A cos A plus sine A cos A. Yeah, so we actually arrive at the first formula. Sine 2A is 2 sine A cos A. Get the idea? So I'll give you 1 minute. I want you to figure out what the formula for cos 2A is. Again, by using the compound angle formula from last time. No, write it down, work it out. Write it down and work it out. So you should say cos 2A is cos A plus A. Cos 2A is cos A plus A. Oh, yeah.
1 minus 2 sine A square. Minus sine A square.
Yes.
Minus sine A square.
That's it. Cos squared A minus sine squared A. Yeah.
Oh, yes.
Yeah.
Square, yes.
No, it's not.
Yeah.
And now, take a minute and get tan 2A using the formula from the last lesson.
So do we have to prove this?
Now, yes. Because there is a special lesson at the end of this chapter called Proving Trigonometric Identities.
Use last lesson.
Yeah, well, for this one you can use the last lesson to prove this, so it's fine.
Do you have formula for this formula book?
I don't know, because they keep changing the formula book. They emailed me the newest one about 4 weeks ago, 5 weeks ago, so I can check, but I believe on Moodle I put the newest formula book there, so you can check it on Moodle. Okay? Do we have a tan 2A?
Long 2 minus over 1 minus A.
Yeah? Okay. Continue. Let's have a look at some examples now. Now some of these can be pretty tricky, so let's have a look at an easy one to start with. So I'll give you 2 examples to try, which I'll do. So the first example and then the second example. And the first example will be easy peasy. I'll tell you tan A equals 3 over 4. I'll also tell you that A is acute, and I'll want you to find tan 2A. And then for the second example, which is a little harder, I tell you tan 2A is 5/12. A is acute. Find tan A.
Wow.
Pleasant.
Can we find the angle?
Don't do that. I told you last time not to do that.
Oh. Small
Hail. Hail and ice.
What is the difference between Q? Oh, Q. Whatever. And I.
Hail.
I'm so fast.
Interesting. Hail is a bit weird because they're like little stones. Well, no, they feel more like stones than ice. Because ice, it's like it's just water, but they almost look and feel like little stones. I hope you have the first part done because that's kind of straightforward. So the first part, tan 2A, is 2 tan A over 1 minus tan squared A. Like this, yeah? So what's that? 3 over 2 over 1 minus 9 over 16, isn't it? 7 over 16, is it? Here, is that right? 16 minus 9 is 7. And then that's a 2. So that's equal to 48 over 14. Or 24 over 7. That's what I got. Yeah? But now the next one is a little bit harder. Fractions, Jerry, fractions. Fractions. I want fractions. Fractions. You know fractions?
No.
You don't know fractions?
Wow.
Okay. Oh, okay. Excuse me.
Wow.
Seems believable. Trust you.
Oh my god, that's insane.
I trust you.
Wow.
Did you get an answer?
Yeah.
Yep. So, I thought this was a little bit harder, but you all figured out that you end up with a quadratic. Yeah, so there's no need for me to do this one?
Yeah, you have to. Oh, there's no need.
Sorry, Lee, you need to keep up with the rest of the class now, okay? We can't go at your slower pace. Alright, I'm sorry. Okay, let's find it.
I have a question.
Is it a good question or a stupid question?
I mean, for me, it's a good question. Why do we ignore the negative one? I mean, it can. Oh, it can be a Q. Okay.
It was stupid question.
Leave him be. Right, let's find a juicy one. A juicy one is like this one. So, tan 2A equals 240 over 161. A is acute, and 2A are both, actually I'll just draw it as a circle. Both A and 2A are in quadrant 1, and I want you to find, yeah, well actually for this one let's say cos. Now that's juicier.
Yes.
That's juicier. But even that isn't too difficult.
One cosine.
Oh man, I'm so hungry. Chew, what have you got in your lunchbox?
Just like soup.
Are those the jelly beans from yesterday?
What?
Oh man. Don't you have anything I like? That's okay.
Like fishy.
Oh, my choices are jelly beans or fish sweets. I'll pick jelly beans.
Oh.
Easy peasy. Not super easy, but it's kind of not too different to the last one. In fact, what's easy is to do here first is to find tan A. Now, we have tan 2A is equal to 2 tan A over 1 minus tan squared. Cross multiplying, I get 240 minus 240 t squared, 322 t. So I get 240 t squared plus 322 t minus 240 equals 0. Well, I can definitely divide by a number. What is the biggest number? Can I divide this 24? Does 24 go into 322? Is it? 322 divided by 24? 12? No. 6, 7, 8.
No.
6?
No.
7?
Yes, 7. 46.
So 7 into...
5. Yeah.
Alright, well anyways, I know 2 goes into them.
160. No.
That's it! Alright, let's factorize.
Why don't you just put on the calculator?
No, that's for babies.
I'm baby.
No, let's factorize this. Right, we need two numbers that multiply to make 120 and add to make 161, and then two numbers that multiply to make 120.
You and you.
17 here, I think. How many times does 17 go into 120 now exactly? What? Yeah, what's 120 over 17? It doesn't? Ah, well, there's 15. 15, that's actually 15 is a better number. 15 and 7.
Yeah.
Right. That's 8 here, is it?
No.
Or 7, yeah. No, don't help me.
8.
15 times 8 is 120. Everybody knows that.
And 8 over there.
Now. 8 here.
Yeah.
That would make 64.
16 over
So I need 6. That would make 90 and 64. No.
16.
Oh, minus 8, and then 16.
15?
Yeah, minus 8 plus 15.
Yeah, 15.
64 and 225. Yeah,
Correct.
okay. So tan is, no, don't be impressed by that, that was pathetic. Or minus 15 over 8. But of course you have to reject this answer because I tell you that A is in the first quadrant and 2A is in the first quadrant. So this is it. Well, actually this isn't really the answer because that's only the tan in the first quadrant. Is this a 16 or 17? So, what did I want? Cos A, was it?
15 over 17.
Yeah.
Yeah.
Not actually not that hard. Not that bad. I normally see these questions as a section A trigonometry question for like 4 or 5 marks. Which is alright for 4 or 5 marks. Anything juicier than that? I don't think so. I don't think it gets any juicier than that. They're not as hard as they look. Like for example, if I said what's sine 4A, that would be the same thing as sine 2A, which would be 2 sine 2A cos 2A. It's as if the 2A is A in the double angle formula. Yeah?
Yes.
So then that would be 2 sine 2A is 2 sine A cos A, and then cos 2A is cos squared A minus sine squared A. I don't really want to have, for this question I don't want to have cos in my answer, if that's possible. Oh, in this one I do, but in the next one I only want sine A. Okay, well then, is there anything I can do to clean this up? No, I could multiply it out. What's it going to be? 4 sine A cos cubed A minus 4 sine cubed A. Right, let's try cos 4A. This one's a bit more interesting because I say give me cos 4A but only using sine A. So cos 4A is the same thing as cos 2A, which is the same as cos squared 2A minus sine squared 2A, which will be squared minus squared. Sine 2A is 2 sine A cos A, and cos squared 2A, cos 2A is cos squared A minus sine squared A. So I don't have to keep writing cos and sine, I'll just use C and S. C squared minus S squared squared minus 2SC squared. Now I said I only want sine. So I'll change this cos squared into 1 minus sine squared. And this will be 4 sine squared cos squared. And this will be 1 minus 2 sine squared. And this will be 4 sine squared, and cos squared will be 1 minus sine squared. What square? Here? Oh. Like that. So that will be 1 minus 4 sine squared plus 4 sine 4 minus 4 sine squared plus 4 sine 4. So the answer is 8 sine 4A minus 4
8 minus 8 sine squared plus 1.
That's cos 4A.
This belongs to the cos 4A cos 2A plus 2.
Oh, that makes baby Jesus weep in tears, because if you remember at the very start of this topic, remember I said cos A plus B is not cos A plus cos B.
Oh, not having cos into brackets 2 is that 2.
Okay, I take my previous statement back. You meant cos bracket 2A plus 2A close bracket. That is totally acceptable.
Acceptable for cos 2a plus cos 2a.
No!
Oh, okay.
That makes baby Jesus
Yeah,
cry.
I was
Yeah.
sure because you said yes.
You have this expression in Kenya, don't you? That makes baby Jesus cry? You don't! That sounds blasphemous. Yeah. Yeah, maybe it's more of a Western thing then. Okay, what is interesting about this one, the reason I have it in the workbook, is, believe it or not, it doesn't matter, like this could be 8a or whatever, you can actually always write it as a sum of sine a's. Now, they might be squared or power 4, but the point I was trying to make with this question is, it's actually possible to take double or quadruple or triple angles and simplify them down into single angle problems using these formulas. It's something that's actually related to what we were saying about Fourier series before. Because this cos 4a is a wave, but because of the 4 it's quite a compact wave, so it would look more like this. Because of the 4 reduces it 4 times here. But this can be written as a sum of just simple sine waves, but maybe some of them are squared. Anyways, you might study this more at university. So if you want to try these for a few minutes, and then we'll just leave it there. Yeah, try these for a few minutes.
Try